Hello everyone, my name is Jiaming Xing and I will show you guys my homework for probability theory. The first question, we are given that y equals to gx and we want to find and draw the CDF and the PDF of the random variable y in terms of the PDF and the CDF of x. The graph of y equals to gx and fx is shown on the paper, and we find that y equals to gx is a function that when x is less than 0, it equals to 2, and when x is more than and equal to 0 and less than 1, it equals to 0, and when x is more than and equals to 1 and less than and equals to 2, it equals to minus x plus 1, and for x is more than 2, it equals to minus 1. And we find that the range of the y belongs to minus 1 to 1. And the CDF of y must be continuous and an increasable function. So maybe we can just find the CDF of y first. When y is less than minus 1, it equals to 0, and when y is more than and equals to 2, it equals to 1. So how about when y is more than minus 1 and less than 0, and y is more than equals to 0 and less than 2? So according to the CDF of y, when y is more than minus 1 is less than 0, the CDF of y equals to the probability of y is less than y. According to the graph shown on the paper, so when y is more than minus 1 and less than 0, so we can find a solution of x2 in terms of y. So the probability of y is less than y equals to the probability of x, the random variable x is more than x. So it just equals to 1 minus the CDF x of 1 minus y. It is the same method of y when y is more than and equals to 0 and less than 2. It shows that the CDF of y equals to 1 minus the CDF of x when x equals to 0. So it's just the formula of the CDF of y. And then we want to find the PDF of y. It's just the derivative of the CDF of y. But there is some step jump on the some point. For example, the probability of y equals to the probability of x is more than and equals to 0 and less than equals to 1. So it equals to the CDF x of 1 minus the CDF x of 0. And when y equals to minus 1, the probability of y equals to minus 1 equals to the probability of x is more than and equals to 2. It equals to 1 minus the probability of the CDF of CDF x of 2. And when y is more than minus 1 is less than 0, the probability of y equals to y equals to the probability of x is more than 1 minus y. So it equals to 1 minus the CDF x of 1 minus y. So it's just the formula of the PDF of y. And when y is more than minus 1 and less than 0, we want to find, we can find the solution for gx equals to minus x plus 1. The solution of x equals to 1 minus y. So the PDF of y just equals to the PDF x of the solution x divide the absolute value of the derivative of gx when x equals to the x solution. It just equals to the PDF x of 1 minus y. So then we can draw the PDF of y and the CDF of y in terms of the PDF and CDF of x. The CDF of y is just like this picture. When y is more than 2, it equals to 1, and when y is less than minus 1, it equals to 0. But when y is equals to minus 1, there is just a step on this point, and when y is more than minus 1 and less than or equal to 0, it's just a continuous cursive. So there is the graph of the PDF of random variable y. There are 3 step functions on the when y equals to minus 1, y equals to 0, and y equals to 2. So that's the solution of question 1.